We've solved systems of equations two different ways so far. We've solved it by graphing, and we've also solved it with the a substitution method. So here is going to be another piece of vocabulary that you need to know. Today we're going to solve systems by the elimination method. So you'll need to recognize that and know what it means. Now, very simply, I'm going to come down and just do this example. What we're going to do is we're going to add these two rows together. I have two equations. It's a system. And I'm going to add x plus x and get two x's. Y, a positive y and a negative y is 0, and they eliminate. And then equals 5 plus 7 is 12. And that's where the word eliminate comes from. I'm going to add, and those get eliminated. So I get 2x is 12. So now I'm going to divide both sides by 2, and I'm going to come up with that x is equal to 6. Once I find that x is 6, I can plug it into either one of these equations. It doesn't matter. Pick the easiest one, but they both look easy. So I'm going to put 6 in for x in the first equation. So I'm going to have 6 plus y is 5. Then I'm going to subtract 6 from both sides, and I'm going to come up with that y is equal to negative 1. So my solution then is going to be 6, negative 1. So remember, the nice thing about these is that you can check them. So into my first one, I'll have 6 minus 1 is equal to 5, and that checks. And into the second one, I've got 6 minus a negative 1 is equal to 7. So 6 plus 1 is 7, and that checks. So this is like the simplest of the simple elimination problems. I didn't have to do anything. I just added, eliminated, and solved. So they do get a little bit more complicated, and here's the things we'll need to do. We'll need to have our equation in standard form. So remember, that's an x, then a y, and then it equals, and then our number. And of course that means no fractions. We don't want to work with fractions down here. If necessary, we're going to also do some multiplication, because not always will it be so pretty as this. So we're going to do some multiplication so that the coefficients of variables are going to be opposites. And we'll have to find an LCD or LCM to do that. We're going to write the equations one above the other. We're going to add them together, and hopefully we're going to eliminate a variable, and then we're going to solve for the other one by substituting. So then, because we did do some substitution there when we substituted the 6 into that equation. All right, the second one, B, is very much similar to that, so I'm going to skip it. So in example 2, when I go and try to add like I did on the last problem, I'd get 7x, and I'd add this, I get negative 3y. So neither one of my variables eliminated. So to get them to eliminate, I need them to have the same coefficient. One of them be positive and one of them be negative. Now the easiest place we can make this happen is to multiply through this first equation so that my y is going to have, this is a negative 4. I want the opposites, want positive 4 in this spot right here. So I'm going to multiply through this equation by 4. Now when I do it, I'm going to multiply through every single term, just like when we're eliminating fractions. And when I do that, I'm going to get 4 times 4x is 16x, 4 times y, so it's going to be plus 4y, and then 4 times 5, so it's going to be equal to 20. Now I'm just going to copy this over right here, so I'm going to copy it and put, oops, 16x. I left my x off right there, so get that x fit in. So then I'm going to write underneath it 3x minus 4y is equal to negative 1. So I just copied that over. You have to be very careful not to make a careless mistake. When I add these, I get 19x. That doesn't look very pretty. These are going to eliminate. But when I add these, 20 and a negative 1 comes out to be 19. So that's looking nicer. So then I'm going to divide both sides by 19 so that I end up with that x is equal to 19 divided by 19 is 1. So there's one piece of my answer. So I'm going to take my 1 and I'm going to plug it in for x, and it doesn't matter which of these I plug into. And I'm going to plug it in over here before I changed anything, so back to an original. So it doesn't matter, but their numbers are smaller. So I'm going to take my 1, I'm going to put it in for x. So I'm going to have 4 times 1 plus y is equal to 5. So that's 4 plus y is 5. So then I'm going to subtract 4 from both sides, and I'm going to get y is equal to 1. So at this point, my solution appears to be 1, 1. Now I'm going to check it, and put a 1 into the first one, and I get 4 plus 1 is 5, and that checks. And then I'm going to put 1 and 1 into the second one, and that's going to give me 3 minus 4 is -1, and that also checks. So there's my answer.